Hello, welcome back to my channel, and this is Ethereum Protocol Studies, where we take a concept and try as much as possible to explain it for better understanding. Okay, and my name remains Ifediora Emmanuel. I'm a blockchain enthusiast and also a protocol engineer in the space. So today we're going to be talking about block validation, what block validation means. We're going to explain what a block is. We'll talk about what block validation is, then we'll try to understand why exactly a block needs to be validated. So then after that, we'll look at what block validation is from a technical standpoint. Under that, we'll look at the process behind block validation, look at transaction verification, look at block structure validation. Then we'll talk a bit about state transition. So let's dive right in. So what is a block? So a block is basically a collection of transaction and other metadata, such as the hash of the previous block before it and the hash of all the transactions in that current block. So that is what a block is. So a block is just collection of transactions and other metadata that is being added to the blockchain. So what is block validation? So block validation is actually just the process of verifying that a block in itself complies with the Ethereum protocol. So it's just a process of checking if a block actually follows the rules that are set by Ethereum protocol. So that being said, we'll talk about now. Let's talk about why block validation is actually important. So block validation is important because it helps protect the integrity, the security, and also the consensus of the Ethereum blockchain. It helps protect the security, it helps protect the integrity, and also the consensus of the Ethereum blockchain. So now we're going to look at the process behind block validation. First of all, we'll talk about transaction verification. What is transaction verification? So transaction verification is actually the process of checking each transactions in that current block that we are trying to validate. So when verifying a transaction, we are basically checking for correct digital signatures, checking for sufficient gas fees, and checking for valid nonce values and all of that. So that is how a transaction is being verified. So we look at also block structure validation. We're actually validating the structure of a block, making sure that the block contains what it's supposed to contain. So one of the content of a block, like I said, is the transactions. Then we have the hash, we call it the parent hash, which is the hash of the previous node before it, and also its current hash and timestamp. So basically, while validating the block, we're checking if it has the correct block header format, which contains the parent hash, the state root, the receipt root, and all of that. Then we check for valid timestamp, actually checking if the timestamp of that block is valid. Then we also check for gas limit and the gas used. All of these are implemented in Go Ethereum client. So with that being said, we look at state transition. So as we all know, we know that Ethereum is a state transition machine. What I mean by that is whenever a block is being added to the Ethereum blockchain, it changes states. So it changes state from the previous state it was previously in to the new state after the block has been added. So that is what state transition is all about in Ethereum blockchain. So anytime a block is being added to the blockchain, state transition always occurs. So here it says verify that executing all transactions in the block results in a new state change. or in a new state. Exactly, that is what state transition is all about. So that is all for today's video. When next we come, in my next video, I'm going to be walking you through how block validation is being implemented in the Go Ethereum client. I'm going to be doing a walkthrough of block validation, how it is being implemented, or how it was implemented in the Go Ethereum client. Thank you for watching my video. Peace.